Hey guys, Buildzoid here from Actually Hardcore Overclocking, and today we're going to be taking a look at the ASRock Z490 Phantom Gaming Velocita, a motherboard that is both pretty interesting and extremely disappointing. So when I first saw this motherboard, I got really excited because I was like, oh cool, we're going to have a $200-ish motherboard with a postcode. That's going to be great for like budget overclocking. And then a couple days later, I saw the retail price on Newegg, and the board is $260. My disappointment was immeasurable. However, my day was not ruined, because luckily there are plenty of other better Z490 motherboards at lower prices, equal prices, higher prices.
Before that, this video is brought to you by Gigabyte Aorus RTX 2080 Ti Extreme. The RTX 2080 Ti Extreme is built with a triple axial cooling solution and ready for anyone interested in intermediate GPU overclocking, although it's also up for gaming out of the box. The Gigabyte 2080 Ti can reach the higher performance range required to play games at frame rates at and beyond 144 FPS, coupled particularly well with games like Call of Duty Warzone, Rainbow Six Siege, and other competitive FPSs. Gigabyte's Extreme is built to be a looker for system builders going for extra visual flair. Learn more at the link in the description below.
Like, basically, I can't think of a single reason why you'd buy this board when you can get basically the entire feature. Actually, you can get better motherboards with better feature sets, better power delivery, basically better everything except the postcode. Like, the only reason to buy this motherboard is the postcode, because everything else, and maybe the 8 SATA ports, because everything else you can get better or cheaper from somebody else. And the thing is, the postcode, like, I love postcodes, but I'd also, like, I like my postcode attached to a good motherboard. And I can live with a good motherboard that has debug LEDs. It's not like this is trash. I just feel like it's about $60 overpriced. So let's get into it. So, you know, pointed out the postcode already. You also get a power and reset button. Not that those, like, to most people, these are completely pointless. I like them because I use test benches. But yeah, to most people, those are completely pointless. In the rear I/O, we get 2.5 gig Realtek over here, 1 gig Intel. So this is actually kind of a unique feature for this price range. There's just one problem. The MSI Z490 Tomahawk exists, and it has dual LAN, and it's like $190. Yeah, it also has a better VRM, but like, you know, it used to be that ASRock offered like really good value, like good performance per dollar motherboards. For Z490, it seems like they've just decided that they don't care at all, and they're just putting out motherboards where it's like, well, this is disappointing. Speaking of disappointing, this is an ATX motherboard with the USB port configuration of an ITX motherboard, and it's not like they ran out of space. I guess, you know, stacking your display port and HDMI port is just way too expensive or something. Also, you'll notice that the board has a position for Wi-Fi that's not populated. Most motherboards in this price range come with Wi-Fi. Just, that's a standard feature at $250. You're like, I don't like Wi-Fi. I don't see the point of having Wi-Fi. Like, personally, I'd prefer my motherboard to be $10 cheaper and without the Wi-Fi, but this is $260, just the same as all the other boards with Wi-Fi, but it doesn't have Wi-Fi. So you're not saving any money by not getting the Wi-Fi. You're just spading, like, you're just not getting it. That's another disappointment. It's also worth noting that basically all of the other motherboards at this price range from the other manufacturers have BIOS flashback functionality in one form or another. This doesn't, because, you know, why would it have that? But, you know, it gets better. The list of things this motherboard doesn't do just keeps increasing. So most motherboards at around $250 will give you 3 16x PCIe slots, which is actually pretty expensive to do because the way that's done, so here what we have is we have this top PCIe slot that's 16x, and that's just connected directly to your CPU. This PCIe slot down here is X4 and connected to the chipset. So for, you know, like, if you have a big heatsink and you can't fit your GPU into this PCIe slot, you're really screwed with this motherboard. Though, admittedly, ASRock recommends that you use this motherboard with water cooling. I'd recommend you just don't use this motherboard at all. Like, you know, because it's just so disappointing in so many ways. But anyway, so with the PCIe configuration, so you only get 2 16x slots, and this is a huge cost saving for ASRock for two reasons. One, you'll notice that we have an AMD Crossfire logo here, but there's no SLI logo. And the reason why there's no SLI logo is you can't run SLI through the chipset. And because you can't run SLI through the chipset, ASRock doesn't have to pay NVIDIA for an SLI license. Fun fact, the board vendor has to pay NVIDIA for having SLI support, like having their motherboard supported by SLI. Essentially, if NVIDIA's drivers detect that you're on a motherboard that doesn't have an SLI license, it won't allow you to enable SLI because, like, it's NVIDIA. Like, what did you expect? That SLI would just work because you have enough PCIe slots for it? On the other hand, Crossfire just kind of works on everything that has at least 2 X4 PCIe slots. Not that that's a great idea. Running Crossfire through a chipset tends to run like absolute garbage, because I've done it, so I know why that's my experience with that. So I wouldn't recommend it. But yeah, ASRock does, you know, they support Crossfire by default. EVGA supports Crossfire, and it's not because EVGA wants to support Crossfire. They just kind of don't have a choice on that. So yeah, ASRock, however, obviously also makes AMD GPUs, so it makes sense that they would advertise Crossfire support. One of the cost savings is just like not having an SLI license. The other big cost saving thing is the way the third PCIe slot on all the other motherboards is implemented is you take this you take that 16x from your CPU and you take 8x of that and shove it into a bunch of PCIe 4.0 switches. And you might be like, why would you use PCIe 4.0 switches when 10th gen doesn't support PCIe 4.0 yet? Well, the reasoning is that 11th gen does support PCIe 4.0. So when 11th gen comes out, the motherboard has to be PCIe 4.0 compatible. And so Asus doesn't advertise PCIe 4.0 compatibility, but as far as I know, basically everybody else has PCIe 4.0 compatibility. So I would assume Asus has it, they're just not talking about it. Or they don't have it and they're actually using PCIe 3.0 switches, which is going to be a very nasty surprise for somebody who tries to install their 11th gen CPU into their high-end Asus motherboard when they realize it forces it down to 3.0. But I doubt that's actually happening. I'm assuming they're using PCIe 4.0 switches and just not talking about it. But anyway, ASRock here, well, they're not doing this, so they don't need the PCIe 4.0 switches, which are relatively expensive, and they also don't need the PCIe 4.0 redrivers, which are also relatively expensive. So ASRock saves money on the SLI license, they save money on the switches and the redrivers, and at this point it's like, so is there anything, like, does this board actually add anything? Because so far we have a big list of things that other motherboards have, and this motherboard doesn't have. Well, I mean, it doesn't get better. So let's talk about the power delivery, right? Because you'd be hoping, so assuming like everything else on this motherboard is kind of cut down, is one way to put it, right? So you'd hope maybe, just maybe, they took all of those cost savings and put them into a better power delivery system. Well, ASRock does advertise this as a 13-phase, and technically speaking, it is a 13-phase. There's just one problem with that. These two phases over here are for the iGPU. So if you have a F-series CPU, these literally don't do anything. If you're not using the iGPU for QuickSync, they also don't do anything. And even if you are using the iGPU for QuickSync, you probably don't need 2 phases of iGPU power to do it. But, you know, that's fine. So, like most other motherboards that support iGPU power will just give you a single phase just so that you can use QuickSync if you want to. Because realistically, you're probably not using the iGPU. Like, you're not going to overclock the iGPU. The iGPU does not pull a lot of power. It doesn't need 2 phases. ASRock gives you this lovely 2-phase iGPU VRM. Then down here, we have a single-phase system agent VRM, which is standard because you do need an actual phase for system agent. So that's nothing new, but everybody does that. Above that, we have an I/O, and they're not counting that into the 13 because this is 2, this is 1, and then this right here, the vCore portion, is 10 phases. And it is actually 10 phases because they are using the ISL 69269 voltage controller. And this controller is actually really cool. It goes all the way up to 12 phases, and here it's running in a 10 +1 +1 configuration. That +1 for, you know, the iGPU goes into a doubler on the back of the board. So that then goes into a ×2. So that's how they get the 2 phases of iGPU. I would have argued they could have not bothered with that, and, well, it wouldn't have ultimately changed anything because the board is still overpriced. So, goes into a times 2. So the V-Core is actually a true 10-phase. Now, that sounds kind of impressive until you consider the fact that Gigabyte will offer you a true 12-phase V-Core VRM for $200. And at around the price of this board, they offer still a 12-phase V-Core VRM. And then also above this, like Gigabyte, basically from $200 to $300, they're using the same VRM with minor design adjustments, but the entire time it's a 12-phase. MSI will, at this price point, I think they actually have a 12-phase. So you could get a 12-phase from MSI, or you could get a 6-phase from Asus, where Asus likes to put 2 power stages in parallel in each phase. So functionally, the Asus motherboard still has more power handling capacity than this board right here, because this is a 10-phase, and it's not like ASRock is using some extra special power stages that nobody else is using at this price point, because these chips right here are just bog standard sort of SiC 63 to a 50 amp DR MOS parts, which basically everyone is using because they're very cost effective. Even the VRM is not real, like it's at this price point, it's just straight up kind of the weakest VRM you can get. In terms of raw current handling capability. In terms of transient response, the thing is, Asus really go out of their way to optimize transient response. Asus essentially designs around the low phase count. Gigabyte at this price point gives you a whole bunch of extra tantalum capacitors jammed into the CPU socket, which ASRock is kind of doing. They have these 2 little tantalum capacitors here, but it's nothing compared to what like Gigabyte is doing. And then MSI's VRM is actually, it looks very standard, but I've also in the past been actually like on MSI motherboards I've actually tested, like they've performed quite well. So from a transient response perspective, I do not think this is going to be the best performing board. I don't think it'll be significantly worse than anything else around this price point. I just doubt it's going to get any awards. Okay, so you have weaker power delivery, and in terms of voltage regulation, it really doesn't seem to be doing anything particularly special. I mean, even inside the CPU socket cavity, we're just looking at a very large array of 0603 multi-layer ceramic capacitors, which I have a sneaking suspicion actually don't work very well because, well, at least on Z490 when I was doing transient response testing, there was a bunch of motherboards which had like really packed CPU sockets, essentially this. And it didn't really correlate with which motherboards were getting the best measurements. So I have a sneaking suspicion that the CPU socket just has too much impedance for this to actually be effective. But yeah, there's nothing really wrong with it. This is standard essentially. So nothing really special in any way, shape, or form here in terms of the power delivery. I mean, like compared to Z490, the 10 phase is cool, but X570 happened and Z490, like you can get 12 phase VRMs on a bunch of boards. So yeah, 10 phase, not really that special. Let's talk about the power handling capacity here. Because it's a 10 phase with these 50 amp DR MOS components, and I forgot to include the A, but the efficiency that we're going to be looking at roughly for 1.2 volts output voltage, 500 kilohertz switching frequency. So 500 kilohertz switching frequency is just what the power stages are spec'd at. So that's what I assume that's what they run at default, because most motherboards using these will actually run them at their default speed. So 1.2 volts, 500 kilohertz switching frequency. You're going to be looking at this VRM being like pushing 200 amps through the VRM to the CPU. This VRM is probably going to produce about 23 watts of heat. Which is not actually that bad, but it's not exactly amazing. Pushing 250 amps, you'll be looking at about 35 watts of heat, which definitely with good heat sinks, that can be dealt with. It's just that the other motherboards in this price range have better power delivery, so, you could just have smaller heat sinks and a better VRM instead. Or then going up to 300 amps output, this VRM will produce about 49 watts of heat, which this is when you start needing like serious amounts of airflow. And then 400 amps output, the VRM is going to be producing probably around 80 watts of heat, which basically is like, give up. Like, don't even try to do that. That is way too much heat unless you plan to attach like a CPU cooler to your VRM. Now you might notice that I started at already 200 amps. So if you're overclocking the 10th gen CPUs, a 10900K can comfortably go between these two figures. So 270 amps is actually very doable on a 10900K, assuming that you have a large enough cooling system. 250 amps is straight up easy to hit. You can do that on an AIO cooler. You don't even need a custom loop. So essentially for a 10900K, you want good efficiency at like 250 to 300 amps. That's kind of the target for a 10900K. 10700K, you're looking at sort of 200 to 250 amps. Again, you can go past 250 on the 10700K as well. The cooling requirements are still like, they're not very practical for a 10700K. So 10700K is going to be sort of like 200 to 250 amps, and the 10600K you can get up to around 200 amps if you're really pushing the CPU. So that's why I started 200 amps. It also does mean that with a 10900K, having the dual 8 pins is actually a good idea. If you're on a 10700K, you don't need to plug in both 8 pins. You can basically ignore this one. And even if you're on a 10900K, ASRock is using the high current variant of this connector, so each of these can actually do at least 480 watts. With the 10900K, you could actually get away with the single 8 pin. It's just that you know, there's no, like, if you have the option to plug in both of them, you should. It definitely won't hurt anything. And if you have the option to plug in like 8 plus 4, you can do that because the 8-pin power connector actually is designed to be 4 4-pin connectors together. So if you just have an extra 4-pin, you can still plug that into the second 8-pin. But yeah, like if you have a standard current 8-pin power connector, like say what MSI is using, that's a 384 watt connector. You can max that out. I've actually measured a 10900K pulling over 400 watts through the 8-pin while overclocking. So yeah, the dual 8 pins are actually not a bad idea. That's actually a good design decision by ASRock right there. Not that they made many of those on this motherboard in general. So yeah, the VRM efficiency here is not exactly spectacular for a 10900K. Like the thing is, ASRock is essentially cheating with their cooling system, which we'll get to. Not really a fan of the VRM efficiency here. Another sort of interesting fact about the design of this power delivery is that there's a lot of input filtering capacitors. Like all of this is actually kind of ridiculous. Okay, well, it actually ends about there for the V-core. Like this down here is for these two phases, and they're not connected to the 8-pin power connectors. Like this is a lot of input filtering that this motherboard comes with. And the reason why it has so much input filtering is for some reason ASRock decided that they don't want to have an input filtering inductor. So essentially it looks like the solution was we're just going to mash capacitors onto this until there's no problem with large transient loads sort of reaching back to the power supply. So this actually, like doing what they've done here, like especially these capacitors up here, those are tantalum polymer capacitors. Those are not cheap. So this is actually kind of expensive, but this looks like something ASRock did to themselves. And I really doubt it has any benefits for actual overclocking, because like just generally speaking, like this is good for like putting less load on your power supply. Or, well, if you had an input filtering inductor, that would also reduce the load on your power supply. Like, essentially, input filtering capacitors are nowhere near as important as the output filtering capacitors. And it's not like ASRock's doing anything particularly wrong there. It's just that, yeah, it's kind of interesting that they decided to not have an input filtering inductor and instead went with all of these input filtering capacitors. Because normally you'd have fewer input capacitors and like at least like one input inductor, whereas ASRock seems to have gone like, okay, no inductor, just capacitors. And yeah, I don't think that actually has any advantages, but you just have to measure with an oscilloscope. The thing is, I keep thinking back to the fact that on at least Z390, there was basically a hard limit to get how good your voltage regulation could be. And it was, again, not really influenced by like input filtering capacitor configuration that much either. So I think they could have done that cheaper. But considering the price of the motherboard, I don't think that was much of a concern. Anyway, since I already, since we're already on the topic of capacitors, ASRock is using FP12K capacitors. So those are Nichicon 12,000 hour aluminum polymer through-hole capacitors. And the cool thing is, well, they're rated for 12,000 hours at 105 degrees, which is the highest endurance rating I'm aware of being used on a motherboard. Most other board vendors around this price point, you're going to be looking at 10,000 hour capacitors, also from Nichicon. The thing is just like your capacitor lifespan increases dramatically the cooler you run them. So if you just have a better, like more efficient VRM with a better better heat sinks, that stops being a concern as well. Also, the thing with the capacitor lifespans is aluminum polymers, they don't dry up or die. Like, they don't outright die after the end of 10,000 hours at 105 degrees. They just get slightly worse at doing their job as capacitors. So they can still go on for, many thousands of hours more. They're just less effective than when they were new. So that's one of the main reasons why they're so popular. They don't really die. They just kind of get worse at being capacitors. And they're not going to unless you can overload them to the point of short circuiting, but generally speaking, that's not going to you'd have to wire them wrong. That's not a concern for motherboard applications. So, ASRock has slightly higher endurance rated capacitors on this board. That's, I guess, the only thing that is better on this board than all the other motherboards in this price range. Now, how did ASRock solve the somewhat less efficient, higher thermal density VRM? Because the other thing with a low phase count or a low power stage count, if you're ASUS, because ASUS doesn't go past 8 phases. If you have a low power stage count, one of the problems is that all of the heat your VRM is producing is concentrated in fewer components. Therefore, those components end up running hotter. Not only do you have the effect of lower efficiency because you have less power handling capacity in the power stages that you do have run hotter because there's less of them. So the heating effect is doubled because it's worse because of the efficiency, worse because of the low component count. Now, if we look at the cooling system, we can see that ASRock chose the lazy, low-effort solution to fixing your thermal issues, which is add a fan. But, the funny thing is, the first fan that, I'm not sure which fan they added first, but, yeah, they added 3 fans. Because, obviously more fans, more better. Except this is the thing I really dislike about this heatsink design is the fact that they used 3 fans for doing something that could have been achieved with 1, because essentially their heatsink looks like an L shape, right? So if you just stick a fan right here and then have the airflow channels sort of like that, you can actually have 1 fan push airflow over the entire VRM heatsink surface area, instead of this abomination that uses up 2 freaking fan headers that are proprietary connectors. So, they are just, why would you do this? Why don't, A, design a better VRM, B, design a better heatsink for said VRM. Don't just whack fans onto your low efficiency VRM with your miserable little heatsink on it. Oh, and it actually gets better, because not only did they add 3 fans, they then realized that fans look ugly. So you've also got a lovely airflow restrictor plate that goes over this fan right here. I can't believe it. What the hell? If this board was $200, I'd get having 3 fans, because designing a, high efficiency, low thermal density, low cost VRM, that's difficult. Okay, that's actually difficult. And in that scenario, if your efficiency is bad, spending $1 or $2 on a fan is a great way of fixing thermal issues. This is a $260 motherboard. They're not paying for PCIe switches. They're not paying for an SLI license. They're not for they have less USB ports than everybody else. There's no Wi-Fi on this. There's no BIOS flashback on this. And apparently all of that was used to purchase a postcode and 3 unnecessary and 3 fans for the VRM. Also, this abomination of a fan header right here, this is stupid. They should have used standard fan headers so that, let's say, I don't know, maybe you are running a 10600K, because with a 10600K, you don't actually need the fans at all, right? Again, I'm assuming this motherboard was actually $200, but it isn't, so don't buy this for a 10600K. But, let's say you let's say you were running this motherboard without, a mega overclock and not pulling that much power through it. So your VRM thermals are good. Or maybe your case airflow is just good in the first place, and so you don't need the extra fans that ASRock put on the bloody board. Well, if they had had any foresight, you could have had 2 extra fan headers to use for your case fans or for your case on the board. But instead, they go and use these 3-pin proprietary connectors so that you essentially have no choice but to use, you can't switch those fan headers over to a better, more useful fan. And it's just like this is stupid. This is just completely ridiculous. Why would you design a board like this? This is completely, at this price point, this is completely unacceptable as far as I'm concerned. This has to be the worst board, the most disappointing motherboard on Z490 for me, because one, you get less everything than any other motherboard in this price range. You get less VRM, you get VRM thermal solution is, the thing is, the fans are going to make this VRM run ridiculously cool. I have no doubts about the fact that this VRM is going to be able to kick out 35 watts of heat and run cooler than every other VRM on the market, mostly because, unlike everybody else's VRM, this one is going to be making noise from airflow. The other ones are probably just going to be making coil whine, but this one's going to be making coil whine and airflow noise. So, it's still going to be louder. Don't do this. Just don't. Motherboard, fans should be used out of necessity. They shouldn't be the first choice, and they certainly shouldn't be used, why freaking 3 of them? 3 with, for a thing that could have been done with 1. I despise the power delivery design of this motherboard. This is, this belongs on a $200 board. For some reason, it's found its way on a $260 board, and I have no idea what they're doing at ASRock. It used to be that ASRock motherboards were, good, performance per dollar, and then you just had to live with the fact that the BIOS was kind of clunky. This motherboard is just bad in every way I can think of, except ultimately, if you measure the VRM thermals, yeah, it's going to run cool. It has fans. If you put a $5 fan on a gigabyte motherboard in this price range, it's also going to run ridiculously cool. If you do that to an MSI board, it's going to run ridiculously cool. If you do that to if you take a $200 board and buy a $5 fan, it's going to run just as cool as this thing. This is lazy design. You don't put fans on your inefficient VRM. At $260, at $150, $200, sure, I could live with that. Those are low-cost motherboards. You can't afford to use proper VRMs, but this, absolutely no. Other things about this board. So now that I've had my little rant about the power delivery here, memory VRM is the classic standard ASRock overkill. Luckily, this doesn't actually do anything, so it's not a good reason to buy the board. So this is a 2-phase memory VRM. Which ASRock really, it's an actual 2-phase. There's a lot of lower, cheaper ASRock boards where you have 2 phases worth of components, but 1 actual phase for your memory VRM. Here we actually have a 2-phase memory VRM. It's controlled by this chip over here, which that's a UP, what do my notes say? 74, P. And yeah, that's a 2-phase voltage controller. We've got 2 dual NFETs, so each MOSFET, you have a low side and a high side MOSFET built into 1 chip. The controller drives those directly. Those are Sinopower SM7341 dual NFETs. That's the same dual NFET that's also used in the VCCIO phase over there. Oh, and the VCCSA and VCC and iGPU phases also use the 50 ampere MOS parts. Anyway, so, 2-phase memory power. Now, in all of my memory overclocking experience, 2-phase memory power doesn't do anything. It's not about how you power your DDR4. It's much more about what you do with your actual memory trace layout between the CPU socket and the memory sticks. And to that extent, we can't see anything, which is a good thing. We can't see any memory traces because ASRock has put ground shields over all of the the important traces, because we do have all of this right here, but to my understanding, these are for signals that are less sensitive than the traces that run through this area. I've not actually ever bothered to check a pinout of a DIMM slot. It's not something I'm that interested in. Well, actually, no, I've checked it, and then I promptly forgot what it looked like. So, Yeah, anyway, the ground shields are good though because they help with essentially blocking EMI from getting to the memory traces and potentially optimizing the impedance of the memory traces. So, yeah, like Gigabyte Z490 motherboards in this, actually Gigabyte Z490 motherboards also do this. Asus is doing, I don't know what Asus is doing with their traces. MSI is using a completely unique topology style that we'll probably cover in a different video. But yeah, like having ground shields over the memory traces is standard for a lot of the X570 motherboards. It's also going to be featured on a lot of B550 motherboards. So this works. This actually helps with high frequency, like high memory clock speeds and that kind of thing. That's part of the topology. The other part of the topology is this is a daisy chain. So essentially, and the motherboard is a 6-layer PCB. So we've got a 6-layer shielded daisy chain memory topology, so that means these 2 DIMM slots are priority for, 2 DIMM overclocking, 4 DIMMs. For Z490, like, I'm not sure how it is on ASRock, but in my experience, at least with other Z490 motherboards, 4 DIMMs actually work just fine on daisy chains, even above 4,000 megahertz. So it doesn't have as much of a negative impact as I assume a lot of people expect it, like, would assume it would have. Like, I've even had 4400 work on a daisy chain. It's just that the timings were really loose, so it wasn't really worth running. We've got a 6-layer shielded daisy chain topology here, which is pretty standard, like, which is one of the options for 6-layer daisy chain topologies on Z490. So Gigabyte's also doing shielded daisy chains. MSI is doing like tabbed daisy chains, and Asus is doing I don't know what, because they like Asus calls their memory topology Optimem something, and it's like that doesn't actually tell you what they're doing. So it's just like, well, that's a cool marketing term, guys. I just have no idea what that actually means. ASRock claims that they're capable of doing speeds up to 4600 plus, which is kind of on the low side for Z490 motherboards. At the same time, they might actually just be more realistic than some of the other vendors. Some of the other vendors often will advertise speeds where it's like, there's very few CPUs that'll actually be able to sustain them. And 4600 is definitely, like, it's not outlandish, but on the other hand, if ASRock is being as optimistic as, historically motherboard vendors tend to be with their memory speeds, then this is about 200 megahertz too high, because generally if a motherboard is spec'd at like it can do 4800, realistically it can run 4600 without having like a golden CPU. If a motherboard is spec'd to do 5 gigahertz, realistically it's probably going to do 4800. So that kind of thing is also a concern. So yeah, and 4600 is kind of on the low side, so I'm hoping that they're just being realistic instead of they actually have a worse topology than everybody else does, because that's the other way that you end up with a lower speed specification. Yeah, that is the Z490 Phantom Gaming Velocita. It's $260 for a motherboard that, I would pay $200 for it. I wouldn't pay $260 for it. Like, that's it. That's essentially everything I have to say about it, because like there's just like the only thing that's really special about this board is the postcode and then maybe the 8 SATA ports, right? But as far as I can tell, most people care more about having a bunch of M.2 slots more so than they care about having a bunch of SATA ports. So yeah, ultimately, like, and also I think there might be other options for 8 SATA ports. And they're probably ASRock as well. So at that point, I guess, yeah, that might be a feature you might want. But yeah, overall, I am very much not a fan of this motherboard, and I am definitely not a fan of all of the fans. So yeah, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support Gamers Nexus, we've got a Patreon. There's a link to that down in the description below. There's also store.gamersnexus.net if you'd like to pick up any Gamers Nexus merch, like mouse mats. Well, actually, those are sold out as far as I know, like shirts and other stuff, YouTuber merch there. That's it for the video. Thanks for watching, and goodbye.